Alright guys, okay, the first step, I'm going to turn off my grid. I don't want this. Show grid, no. Alright, here we go. So, to follow the instructions, our first step is to make a 12-inch by 12-inch block by 6-inch block. Okay, it's pretty easy. We know how to do that. So let's look here. And you all know how to turn off the grid or type in grid and telling it not to show the grid. Alright, there's a couple ways to draw the block. The first could be to just draw a 12-inch by 12-inch frame, which I'm going to do it that way. So I'm going to draw a rectangle and make it 12 inches by 12 inches. Okay? And this needs to be 6 inches deep. So one way to do that is to copy it, look at it in the side view, click, and then click up again 6 inches. Another way to do this, what's another way to do it? What's your name in that? Next to you. What's her name? Turn her in. Sherry? Sharon? What's another way to do it? Extrude curve. Exactly. See this? You go up 6 inches. And if I turn on, goes to display, see we get that. And then another way to do it is to use the box command. So if we come here, click on box, the other corner of the base. See, I need to tell it, I might want to do it over the top of the square. Basically the same thing. But because, so we could do either of these. I tend to like to build up volumes in Rhino because laser cutting is really my primary fabrication possibility. I'm generally not cutting large blocks of foam. And in general, I would say construction in the United States is, we call it laminar construction. You're generally hanging sheets upon sheets. You have sheets of waterproofing, and then sheets of cladding and sheathing, and then you put sheets of drywall on top of that. And architectures tends to be built in very thin layers, many, many layers. So in a sense, you know, when we fabricate things large, we might CNC mill panels or cut metal panels. We'll see some examples of that today in the design district. You know, but now that we have certain capabilities at the school, such as robotic arms and, you know, 5-axis milling and large-scale ceramic printing, things like that, we can do like volume modeling, and we're going to do some stereotomy exercises in a few weeks, looking at how old masons used to actually cut stones, which is a little bit different. But in this case, we're going to kind of build things up by folding thin surfaces. So one way that we could deal with this would be to take this extrusion and explode it. And now we have, you know, 6 panels, you know, 4 sides, a top and a bottom. So we could do that and delete the top. Maybe delete the bottom. So there's our sides. But let's use this here. Okay? So these are two 12-inch by 12-inch squares, 6 inches on top of one another, right on the origin. So if we look at the instructions again, we need to have a 3-inch by 3-inch aperture through the center. A 3-inch by 3-inch volumetric opening through the center. These are not really rules. These are more just conditions. So let's start with 3, 4, and 5. Okay? So we're going to have a 3-inch by 3-inch volumetric opening through the center. Sharon? Sharon. What's one way that we can make a volumetric opening through the center? basically what we're talking about, guys, are what are called toruses. You see this torus? Not like a Ford Taurus. Do you know what Ford Tauruses are? Still have those? Those are huge when I was growing up. That's a torus. It's a donut. Okay? What we want to do, the easiest way to approach this is in plan, to simply draw. Okay, let's just using a square, the box tool, the rectangle tool. Let's just draw a 3-inch by 3-inch square. All right, this is where your creativity comes in. You can place that anywhere in the square, wherever you want the opening to be. Could be in the center, but I know you guys, like, you like to get creative, so you're going to put it over here. You're not going to want to line it up with anything. You're going to make it 3.1 inches for some reason. Anyway, 3-inch by 3-inch, there it is. Okay? So in plan, it's kind of worked out. And the most basic way to do it would be to copy this from here to here. And then if I loft this, yeah, and then I loft like from here to here, I've basically done the assignment. But you are more complex figures, and we have a few more rules. So one of the rules is that it should be convex or concave. Doesn't it say that somewhere? Should be either convex or concave on the top surface. So let's say this. All right, got 2 rule 5s. Here we go. So to make it convex or concave, it needs to look like that, right? So the square needs to either be recessed, so a little less than 3 inches, or more than 3 inches. My house looks like this. I have these blocks on my house that kind of bulge out. I like convex surfaces, so we'll do something like that. Okay? So to do that, we want to take this one. And again, guys, use the toggle tools, like toggle between, plan, a 3-dimensional view, and the side view. And it's so easy to just move this thing out a little. So I'm going to move it out a full 1.5 inches. I'm going to move it 2 inches. Okay? You see it here? So in section, see, I've moved this one out now. All right, so I've kind of satisfied that criteria. So now I've got convex. Let's see what else it says. I've got this. I've got this. The opening must shift in section and twist in plan within the block. All right, so what does that mean? I recommend that you have an intermediate one. So don't just have the top and bottom. You're going to need to move one up. So let's, see if I copy and paste in the side view, I can just move it up. And you could place this kind of anywhere. I'm going to place it there. Okay, so now I've got 3. So how do I shift it? To twist it in plan, I'm going to take each one of these. I'll start with this one first. And in plan, I'll look at it here. I'm just going to rotate it to get it to twist in plan. So I'm going to rotate one. I don't know where I grabbed it, and I'm going to type 30 degrees. These are arbitrary. You fill in the parameters how you want. Okay, and then I'm going to take this one in the top view. I'm going to rotate it negative 15. Negative 15. Okay, see, it looks like it's twisting. And it doesn't have to look like that, guys. You know, just rotate them. So they're twisting over the course of this. And then it also says it should shift in section. So one way to do that is to take one and let's move it over a little. And then maybe I'll take this one and move it over a little. So these are actually shifting in plan and twisting in plan. And then the last thing we can do is I recommend you take this outer one and rotate it in section. I'm going to rotate it in section. Again, these are not intended to be hard. They're just intended to give you, you'll see with just a few moves, like how interesting this can be. Okay, so I rotated it a little. I'm going to rotate this one a little. All right, I've got my scaffold. I call this a scaffold because now I can kind of construct everything on top of it. And by the way, we could make these slightly bigger. You know, we can make this middle one bigger. So I'm going to scale it from here, like 1.5. Okay, got a larger opening in the middle. I think it's interesting when you look through a volume and you can't see clear through it. This one we really could. If I want to obscure that a little, I'll just move this over. So, you know, to see through it, it kind of has to go like that in a curve. So imagine, you know, the plan of the slow house I showed you in the past. We can't see around the corner. Yeah, so this in section. Again, these, you know, yours, just move them in space, shift them around, and I'll show you the purpose of this now. So I really think this is a very basic approach to 3D modeling. There are advanced, sophisticated ways of 3D modeling, and some people are very good at those things. This is not that, but I'll just tell you often higher level commands and operations can become buggier and less sketch-like. Buggier meaning you don't know why they're not working. You're doing things in order and it's giving you something. And so I always refer to like what's a workaround. So if you have a very complex operation you need to do and it's not working out, just do it manually. And so a lot of what I show in this class is how to manually 3D model things. It's not the most efficient way, but there is an efficiency in what I'll show you, kind of like the folded surfaces we were doing. Triangles are always flat. If you define 3 points in space, it can't not be flat. It's a double negative. That means it's flat. Okay? You can't model a curved triangle by defining 3 points in space. All right? So I'm going to show you how to do that. I'm going to shift my color that I'm operating on. I'm going to make these green. Okay? And I'm just going to start with the top. Okay, I'm going to start here. And if this is a little confusing, see I'm modeling triangles, I'm going to hide things in the background. So I'm going to click on the light bulb. So I'm just doing this. So do you see what I'm doing? And then I'll type planar surface. Didn't do that. Oh, jeez. This will just always work out, and you can always unfold that and make it, laser cut it, and it will stay flat. You don't have to worry too much about it. So I would just go around the edge, filling in as you go. Okay, and then we'll just go through and type planar surface. And if we just keep hitting enter, it'll repeat the last command. And as long as those triangles are closed, this command will work. And if, you know, to verify my theory, it's not a theory, I'm sure it's a geometric law. See that? If you were to click a curve and type planar surface, if it weren't flat and it didn't exist on a plane, it wouldn't work. Okay? So I'm going to unhide the rest of these things. I'm going to join all these surfaces. I'm going to join them by typing join. I'm just going to do that arbitrarily. Okay, so I've got one top surface now. I'm going to hide that so we can do the bottom surfaces now. And remember, I don't really need these curves. Once I have the surfaces, I can duplicate the borders if I need the curves back. Okay, so now I'm going to model this center void here. So I'm going to do it the same way, just through triangulation. And you just decide. So I recommend going from point to edge. One last one here. And now I'll go from here to here. And you may want to try to, like, you know, triangulate in a consistent pattern. So you'll see here I'm like basically the wrong one. Go from here to here. And there really is no right way to do this, guys. You pick and choose, fill it in, be creative. This is like a sketch. I see this as a sketch. So play with the parameters, rotate these things in space, twist things how you want. If you want to make it slightly bigger, the openings, keep one as a 3-inch, but you can play with the size. Alright, so now I like this part. We can just type planar surface, and we can just come through and start to fill it in. Yeah, we missed one. Alright. Looks pretty nice. Okay, let's join all of this. I like to join things just so I can select them in order. I'm going to make this red on the inside. The top is green. So you see that? Can't quite see all the way through it. I think these make them interesting because as you kind of rotate around, you know, if you put a light in there, it would glow, but you wouldn't see the light behind it. Again, up to you. All right, the sidewalls are pretty straightforward. If we wanted to do it, you know, with consistency, some of you have the Tel Aviv Art Museum as your precedent. You know, you might want to model the side like that, or you could model it as a rectangle. We know these are flat. All right, and then we can type planar surface. Okay. I like to get in the habit of just sketching out closed curves and doing planar surface. You can always use the surface tool over here. Rectangular plane, corner to corner. Yeah, look, it's doing it flat. So I prefer to just sketch in 3 dimensions. Just be careful with your snaps. Turn off snaps that you don't need, so you're only snapping the edge points and end points. All right, we're basically done, everyone. Here we go. I'm going to join them. All right, so everybody see that? It's got a nice interior. I would say it has a curious interior. Here's the back side. All right, so if we flip this thing over, you can easily loft from this square to this square. Okay. That's it. We're going to have a good time when we snap all these together. If you want to make this front one larger, you can. Why don't we say have one of them be 3 inches and no smaller than 3 inches? Okay? Does that seem pretty straightforward to everyone? All right, so to this, we're going to have you do a few additional drawings now. I'll show you these on Wednesday, but for Wednesday, that took us like 15 minutes. I really think you could do this in 15, 20 minutes now. Should be getting to the point where you're becoming a bit more facile with these things. We're still developing like dexterity and just a familiarity of rotating things around and stitching them together. But look, that is a complex form. Oh, the last item on the assignment was to, I think, to notch out like X-ray. There we go. It was to notch out 1-inch openings. Let's see. All corners must have 1-inch by 1-inch cutouts for ribs to be fastened together. Why don't we just do these on the back? So the best way to do that is going to be to flip this thing over. And we'll just draw 1-inch by 1-inch cubes. So we'll type 1 inch, 1 inch. Let's make these green so we can see them easily. Make them blue. Okay, we put one here. And truthfully, why don't I hide all of this stuff so we're just looking at this thing. So here's the bottom. It's hard to model upside down, so we'll just hide everything on top. And we'll just copy this. Bless you. All right. And then, Sharon, what do we do now? How do we cut holes where those squares are? Yeah, we could split or trim. So if we do split, let's type split. Split this object. Use this object. Okay? And then we just come through and delete those. Alright. And if I turn everything back on, this way, when I do this, so what we're going to do, so they're all joined together now. We're going to, stack these up like a wall. And we'll rotate them. It'll be a pretty cool wall to look through. This way on the back, we'll take a binder clip, we'll clip it here, and it'll hold them all together. Does that make sense? Okay, so just a basic little detail, but if you all do that every year, those holes are always slightly different sizes. Just go 1 inch by 1 inch. No need to be creative there. Okay? All right, guys. That's it. Does anyone have any questions about this? Yeah? Daniel? No? Yes? I can't hear you. Sorry, say it again.